For decades, gun safe companies have sold you on one big number, the fire rating, 30, 60, even 90 minutes of protection. Sounds impressive, right? But here's the truth most manufacturers don't want you to hear. Those ratings are mostly a myth. A 1 hour rated safe can fail in as little as 3 minutes in a real fire. Today, I'm breaking down the science of gun safe fire ratings so you can make smarter choices about protecting your firearms. Now, heat moves in 3 ways: conduction, radiation, and convection. In a real structure fire, convection dominates. Hot gases and turbulent airflow strip away the protective boundary layer of air around a safe. So heat transfer is dramatically faster compared to static, non-moving air. In lab tests, it's still air. It's an oven test. A house fire is just the opposite. It's a torrent. Air can be moving in excess of 60 miles an hour. Convective heat transfer can be up to 10 times faster. That means the outer steel shell heats up almost instantly. Then comes heat soak. The stored energy in the metal keeps cooking the inside even after the flames have died down. Now, gun-safe fire ratings come from controlled oven tests in still air. They ramp up the temperature of the oven to 1300 degrees and they see how long the inside of the safe stays below 350 degrees. Sounds scientific until you realize real fires are dynamic. Fluctuating temperatures, oxygen shifts, and massive airflow. The results? A safe that earns a 60-minute rating in a lab can be overwhelmed in minutes in a real fire. To give you an example of the difference between convective and static heat transfer, let's say you're home making a frozen pizza. You preheat your oven to 450 degrees. You can put your hand in that hot oven, holding it still, you can keep it in there for quite a while. Eventually enough heat transfers to your hand, it's going to force you to pull it out. Now picture a small jet engine where the exhaust gases are the same 450 degrees, but it's coming out of the jet at 60 miles an hour. If you put your hand in that exhaust stream, you're going to have horrible third-degree burns in less than a second. You'll probably lose your hand. Heat transfer is dramatically faster when the air is moving. As you can see, the surface temperature of your safe goes to 1200 degrees in 2 minutes in a convective fire versus 600 degrees in 12 minutes in a static oven test. This is Newton's law of cooling, which also applies to heating. Q equals H times A times delta T. This tells us how much heat is pouring into the gun safe. Q is the heat transfer rate, H is the convective heat transfer coefficient. Now this skyrockets when the air is moving. A is the surface area of your safe, and delta T is the temperature difference between the safe and the fire. In a real house fire, the moving air and the flames make H much larger. So even though the safes have the same surface area and temperature difference, the rate of heat transfer, Q, becomes massively higher, which is why the outer steel heats up almost instantly. Now let's talk about heat soak. Heat soak is what happens when the fire has moved on. The steel walls have absorbed a huge amount of heat energy, and now they release that to the inside of the safe. It's like a giant heat battery. A heavier gauge or thicker steel safe has a high thermal mass. It soaks up a massive amount of heat during a fire, then keeps radiating that stored heat into your guns long after the flames are gone. A thin-walled safe, 14 to 16 gauge, has a low thermal mass. It absorbs far less heat, so once the flames have moved on, there's much less energy to cook your guns. The bottom line, in a real fire, thicker steel, heavier safes actually perform worse than lighter, thin-walled safes. This is due to the prolonged heat soak. Now to hit those fire rating numbers, safe manufacturers line their safes with drywall, gypsum board. The moisture in the gypsum absorbs heat and turns to steam, which works great in an oven test. In real fires, the outer steel heats up way too fast, and the benefits disappear. Worse, the drywall creates a corrosive environment inside your safe, releasing moisture and sulfur compounds. That's why the industry sells millions of dollars a year in anti-corrosion products. The bottom line, fire ratings aren't fraudulent. They're just misunderstood and heavily overmarketed. And in today's reality, the actual risk of a fire is incredibly low. Residential fire risk has been declining for decades, yet companies still push this as the #1 feature. Will your fire-rated gun safe survive a fire? Probably not. Focus instead on how the safe actually stores guns and gear. real construction quality, fast, reliable access, and materials that won't corrode your firearms. And never forget, your ability to quickly access a firearm in a crisis is far more important. So don't fall for simplified labels. Protect your guns with engineering and scientific reality, not marketing myths. Now, if you want real fire protection, not just a marketing number, you need to look at filled safes. These are double-walled steel safes filled with a concrete composite material between the walls. Now, here's why they perform so much better. The thick composite material acts as a true thermal barrier. It absorbs and dissipates heat far more effectively. Unlike thick plate steel, the composite doesn't store and re-radiate massive amounts of heat soak into your interior. The double steel walls provide support, while the concrete composite gives you an incredible level of security and genuine fire resistance. If you decide you need this level of protection, you need to look at our TrueSafe or AMSEC, American Security Products, their BF series of filled safes, because it actually works in real-world fires. However, when you look at actual statistics, most people don't need fire protection. But if fire protection is critical for you, then you need to look at a filled safe. And here's one final critical point most people never think about. After a fire, you'll never truly know how hot the inside of your safe actually got. In our real-world fire test, we put the fire out when the safe reached 400 degrees. 20 minutes later, the interior of that safe had climbed to 720 degrees, long after the flames were gone. Why is this critical? Well, hardened steel components, like your bolts and trigger groups, start to lose their strength at just 380 degrees. Annealed steel, that's your barrel, begins to lose its temper and its structural integrity around 680 degrees. That means after a fire, your firearms may look fine on the outside, but they can be dangerously compromised on the inside. The bottom line, if your guns have been through a fire, you're never going to shoot them again. The risk just isn't worth it. Look, we've covered a lot today, and I hope the information helps. Please drop a comment or question below. I'm going to try to read and reply to as many as I can. And note, this is our new YouTube channel. If you value the content, please like and subscribe to the channel. There's going to be more videos like this coming. I'm Tom Kubiniec with Secure It. Stay safe, stay prepared.